the two things that I had on for today, I'm not sure if Fatima is going to make it, but we had a spot for Cody because Cody's from MedPlum and he's recently posted that he's run the test and implementation of SQL on FHIR. So I feel like it's a couple of minutes past and Cody's here. Maybe we could just dive into that
Yeah,
and go from
we
there.
can go in whatever order. I'm here. I'll be presenting in Fatima's place. She wasn't able to make it today.
Yeah, okay, great. Well, yeah, let's kick off with Cody and then we can go to Shane after that if that's okay.
Yeah, that'd be probably great because it sounds like Shane prepared materials and I'm just going to be talking. So I don't want to have to follow a fancy presentation. But I'm happy to talk about the MedPlum project and why our customers are excited about it and kind of where we see that heading. For those who are not familiar with MedPlum, we are an open source implementation of a FHIR server and a bunch of additional supporting services, mostly regarding authentication, some data management, some visualization, some workflow automation on top of that. MedPlum is commonly used by digital health providers, ranging from early stage startups who are just kind of building out a new healthcare product, all the way to larger digital health providers such as Roe or 30 Madison, who are serving millions of patients and have kind of standardized on FHIR as one of their internal data models for internal usage. The common pattern that we see there is groups who maybe started with a homegrown EHR for digital healthcare purposes. We often hear people joke about how they never had an EHR, they had a CRM, which happened to have some healthcare data in it. And then as they're growing up, then they need to get serious about standardized representations of healthcare data, making sure everything is filled out in a structured way, having coded representations of everything. And FHIR and supporting terminologies and whatnot are just a fantastic use for that. And so building on top of MedPlum is a great experience. It's a API first, it's a headless EHR, it's very much intended for that use case of people building completely white labeled experiences. So the provider, the patient, nobody knows that MedPlum is under the covers. It's using it as just a pure technology backend. And where SQL on FHIR becomes interesting is in the data analytics and the data warehousing use case. We had a number of features for being able to export FHIR data into a CSV format, that's implemented as a kind of custom FHIR operation where you just call a $ CSV. You can pass in a whole bunch of either like element names or search parameters, and it makes a best attempt at kind of splatting it out into a tabular format in a CSV. Obviously, there's limitations when one, it's a custom and proprietary FHIR operation. And so that's just something new and proprietary that our customers would have to learn how to use. And then two, it was not as full featured as what the SQL on FHIR spec does today. And I believe like aims to do, including like the very rich and structured definitions, like joins and unions and all that good stuff. So I think that's where we're really excited about it coming into play. In the short term, we're primarily exposing it as just an SDK primitive, which some of our customers are already using. And I know that some of them have written tools. So taking a MedPlum server, running the FHIR bulk data export, getting a pile of new line to delimited JSON files on your hard drive, and then kind of cranking through that with the MedPlum client-side SDK to evaluate the SQL on FHIR expressions for filtering and converting that to tabular format, and then pumping that into a traditional data warehouse like a Snowflake or Databricks or whatever you want to use. I think that one of the big draws, we often hear this from our customers of like, we're not so sure about MedPlum, but we love FHIR, which is always a bit of a backhanded compliment, but it feels good in a way because I think that really speaks to the vision of what the FHIR community is trying to achieve. It is about the standards. It is about having a well-defined specification and interface. And I think that SQL on FHIR is just another great tool in that toolkit. Or it's a standardized representation, but it's solving a very discrete and distinct need of, I need this very structured, rich, but nested data into a tabular format. What do I do? So really just excited to have a standardized solution that's going to solve that need. That's the short of it. I'd be happy to take any questions if anyone was curious beyond that.
Well, I've got one to kick us off. So do you have a bulk data export operation implemented currently?
We do. We support the full bulk data API, and I think that there's a bunch of very natural ways that those two things, like the bulk data API and the SQL on FHIR standard, could be smushed together into a standardized API. And I think that we're watching that with distinct interest, because I think that that would be very popular.
Hi, thanks for the description of what you're doing. So follow up on what John asked. So is it the way that you currently do this? Is it part of the export, or do you have like an intermediate format that you work off of that to create different views? Or whenever you create view is actually part of your bulk export.
It's a great question. Today, the SQL on FHIR utilities and parsing and execution engine are kind of like a separate library and SDK. And most of when we think of our customers, they are developers, they're software engineers or data engineers who are building solutions. And we view our product as developer tools to help them kind of build the customized solution they want. So we have the bulk data API, and we know that there are some groups who are using the bulk data API. They get their pile of new line delimited JSON files, and then they're writing custom tools using our SQL on FHIR SDK to process that and then pipe it into the data warehouse. So that's, and we don't have it exposed as a FHIR operation today. And I apologize if this is part of the spec. I didn't see it off our initial pass, but I think that that would be fantastic if there was a standardized, $sign FHIR operation to somehow execute the SQL on FHIR, get the results. I think that would be immensely popular, and we would happily implement that.
Yeah, it's not part of the spec as far as I know. I was just curious that if you have gone further and you've done it. So basically, is it fair to say what you do is like a library, like an implementation of SQL on FHIR, which consumes ND-JSON FHIR resources and then creates the tabular format, basically?
Right. You can, it's relatively low level primitive today in terms of how it's exposed in the SDK. You can give it a view definition and a resource and get back an output row, just like this array of strings. You can give it a pile of resources if you have it in array format. I think that it's fine as like a testing utility, but when you're working with like a bulk operation in many millions of rows, you almost need to have it in some kind of streaming and batch operation. And that's why we've really tried to expose it that way, so that our developer customers can kind of come up with the appropriate solution that can take advantage of whatever streaming and parallelizing technology they want to when they're doing the transformations and piping it into a data warehouse.
I see, and I apologize, Dan has his hand up. So basically, you just provide the core functionality. It's not your business or your job of how to scale this, basically, right? Is that fair?
At present, that's exactly correct. I believe that in the future we'll probably find a way to more deeply integrated into the product, both as a server-side operation, and then we have a suite of user interface utilities, kind of like a developer dashboard or developer console, that exposing it as a user interface component there, I think would be another natural thing to do, but we don't have that today. Go ahead, Dan.
Sure, thanks. So yeah, thanks for the overview. That was great. On the API side, I think we've talked a little bit about it as maybe the next thing to work on after we get the spec, just the view definition spec done, because I think kind of everybody is on the page of both APIs to manage view definitions, but also APIs to export into kind of, files that take on view definitions as the structuring mechanism. So I think definitely in the queue for this group, we've talked a lot about it, but have not focused on it yet. But I was wondering if you could talk a little bit more about the technical side of the MedPlum implementation. So kind of language, what challenges you found? Did you guys add additional FHIR path operations that aren't part of the core spec that you thought were useful? I guess just like, I think there's a lot of implementers on the call, and so it's always good to get that implementation feedback, as well as just like some of the parts that were challenging. Just kind of a little more about that detail.
Yeah, of course, I'd love to. So MedPlum is full stack TypeScript, front end, back end. All of our kind of core SDKs are all TypeScript, which has been very, very powerful for us as a full stack team, because we have a bunch of React component library, and then like front end utilities and portals, all of that's in TypeScript. I mean, the whole back end is in Node.js with TypeScript. We also provide some command line utilities. We have a on-premise agent that can run for connecting to legacy devices over legacy protocols like HL7 v2 or DICOM. All of that's TypeScript, which is great. And it also means that when we have a TypeScript implementation of the SQL on FHIR engine, it becomes relatively trivial for us to kind of drop that in to any of those experiences, server side, client side, command line utilities, whatever. So that is the gist of it. I'd say the bulk of the implementation was relatively straightforward. So first of all, MedPlum is 100% open source, Apache licensed, which means that I can go ahead and just like share. There's a link to the, wait, I gotta accept the guest policy. Okay, there's a link to the bulk of the implementation right there. You'll see from the comments that we basically started with the pseudocode that was part of the spec, which was delightful to work with because it is relatively, straightforward, and it maps pretty cleanly to TypeScript line by line. And the whole thing is about 250 lines. So this was not a massive lift. I mean, part of it is our FHIR implementation was a much larger lift and is a lot more code, but that has been running for a few years now and is relatively hardened and battle tested. So by leveraging the FHIR spec, I think that was a great decision, and it made the implementation process about as easy as you can imagine. I'd say, what would I say? I mean, having the test suite was also fantastic. We basically just imported the tests and wrote a very thin shim around the Jest test runner, which loads those specs, runs the evaluation, and compares the results. I believe at this moment we're like a 98 out of 120 or so when it comes to the total tests. And most of the existing failures are due to, we don't support, was it high bound and low bound on some of the math operations, which I think is a matter of just us getting around to kind of grinding out some of those additional FHIR functions. No, by and large, I would not say there were any like major surprises or major challenges. As far as implementation guides and specifications go, this was a pretty delightful one to work with, and the whole thing came together quickly. It was customer driven, so we were aware of the spec, but it wasn't really a priority for us. And I think that some of our customers came back from the most recent FHIR dev days and were very enthusiastic. And they said, oh, everyone's talking about SQL on FHIR. You really need to get this going. And so that kind of lit a fire under us, and we were able to pop this out relatively quickly. So that's the short version of it. I'd be happy to go into any more details if there's any specific questions.
That's awesome. Thanks. I don't know if other folks have questions too, but that was particularly having the link to the GitHub answers a lot of questions because I can just look at the code.
Awesome.
So is it correct that you don't use FHIR.js? And if you don't, then why is that?
MedPlum has a complete clean room implementation of the FHIR spec. As a question of why, there's a few different reasons. We knew that we wanted to run, and I don't want this to come across as critical of FHIR.js. It's been a few years since I looked at it in depth. I believe, if memory serves me correctly, running it on the client side had a bit of a heavy payload due to some of the assumptions about structure definitions being baked in or being available. One of the kind of operating principles of MedPlum is that it should be able to lazily initialize and kind of dynamically accumulate structure definitions from the server and always be operating as you go along. So for example, you can look at a patient, for example, and it'll dynamically go to the server, fetch the patient structure definition, it uses that to hydrate all of our React components so that as you're going along, like patient name, patient address, patient telecom, like that, all of those UI components and everything are derived from that structure definition, which is kind of lazily being imported. Our FHIR implementation is very, very lightweight, and it basically just relies on those lazy initiation of those structure definitions. And I believe when we were doing initial experiments, this is probably 2 or 3 years ago. So again, I apologize if my information's out of date. That was difficult to do with FHIR.js. And so we went crazy, probably a bit of a case of not invented here syndrome, and did our own thing, which is working fine though. Our FHIR implementation is incredibly hardened because we use it all over the place, not just the user interface, but on our server side, for example, we pre-compute all search parameters into relational database columns. And so on every FHIR write operation, we're going across all search parameters, evaluating those FHIR expressions to dynamically compute the values into those columns, which I don't think is particularly novel. We're doing it at scale with, tens of millions of resources in the database, and it's been working well for us so far. So I don't know if that's a good reason or good justification, but I think that's kind of how we ended up where we are.
And what does your data store look like? How can it be queried? Did you consider a different way of implementing this in terms of translating a view definition into a query rather than processing the data sort of outside of the data store.
Yeah, that very easily could be done. Like I said at the top, I think that our short-term goals were enabling our customers who are developers and providing them with primitives that they can use for building their own experiences. It would not be a difficult thing for us to do on our server-side implementation to basically accept a view definition and convert that into SQL filters, because that's more or less how the MedPlum server works already. It takes all of that URL query string, all the search parameters, and it's just translating that into SQL search features, including very complex nested joins, nested queries, and whatever, to be able to support all of the complexities of FHIR search parameters. So I think taking that model and applying it to a view definition would not be a major lift, but that wasn't our Pry1 goal at the time. So we started with the simple thing first.
Okay, that's awesome. If there's no other questions for Cody, thanks very much for giving us a bit of an overview of that. I know that I'll certainly be diving in and having a bit of a closer look at what you've done and seeing if we can get any extra learnings from that. I think now might be a good time to move on and let Shane have a bit of a talk and see what sort of discussion that throws up.
Cool. So I'm going to talk about our implementation of SQL on FHIR, which is, we've been offering it to customers now for like about 2 years. It's taken a little bit of a twist and turn. So I thought maybe I'd just start at the beginning to kind of walk through some of the challenges we've encountered and how we've made changes to improve the product and kind of where we are current state with our implementation of SQL on FHIR. So with that, everybody see the presentation okay? Yeah, so a little word on terminology, I guess. So for the Gen 1 product, we called that SQL on FHIR. The next iteration, we actually renamed the product so the way that we market it is called One-Up Analyze. So I know there's a little bit of a discrepancy in terminology there. I think most of the community is still using the word SQL on FHIR for, of a SQL database directed at FHIR data. So in any case, the first database we used was actually AWS Athena, which is Presto under the hood. And the data store at that time was Delta Lake using Parquet files. So our ETLs at that time were run through Spark that were kind of orchestrated and timed through we ran into, but really the main thing was capture of semi-structured FHIR data in Parquet. And when it comes down to like schemas and things like that across a multitude of customers, it became difficult to manage and difficult to predict sometimes whether or not we'd be able to capture all of their attributes depending on paths with a single schema. Authentication on Athena works by IAM, which is not really a great way to go about things. It's kind of difficult to maintain across a multitude of customer accounts. So that was also definitely a factor in why we decided to move on. So the Gen 2 product, now called One-Up Analyze, is built on Redshift. We've built out our ETLs using Kinesis and Firehose mainly, and AWS Batch. AWS Batch, if you're not like an AWS user, and I guess I can explain Kinesis and Firehose too, but Batch is basically a queuing system wrapper around ECS, which is container service. So most people are probably running like Docker containers and things like that through Batch and running compute there. So we saw quite an improvement in cost for our ETL processes. Kinesis is kind of, well, it's Amazon's streaming service. Maybe that's common knowledge and I don't need to discuss too much about it. Really one of the biggest advantages probably is schemaless and lossless capture of FHIR data. So in Redshift, they have what they call the super data type, which is able to capture JSON data without a predefined schema upfront, and also allows access to attributes either via dot notation or nesting, things like that via cross. Performance has been really pretty remarkable. One of the first things we did was we spun up a test cluster with synthetic data and found that, really like the smallest cluster you can provision, a single node cluster using the smallest node type, outran Athena about 10-1. So it was kind of like, wow, okay, that was a noticeable improvement. Predictable cost is also a really nice factor. It's just easier with clients and customers to wrap contracting and understand what costs will be for usage of the cluster, of capture of data. So basically in AWS, you're going to provision a Redshift cluster and you can run as many queries as you want, depending on the performance. You can fill your disk, whatever you want. Really, what you're paying for is just that provisioned resource. So there's no other costs involved. Of course, they have different pricing models where you might prepay for your resources, and then you can see up to like about a 70% reduction in cost. But versus the Athena solution, we saw about a 5x reduction in cost. Authentication and access improvements are also notable. Authentication is basically you're just creating user accounts on the cluster for your client, and then you have your usual access controls like schema, table, field, but then in addition, Redshift has an implementation of role-level security. So you can actually define criteria that are used for filtering actual records that are returned at query runtime. So kind of, I think the elephant in the room for a lot of folks when it comes to creating a SQL system is, well, how do I take my JSON object, my FHIR object, and translate that into a tabular structure, right? Like how are we going to do that with a flexible format like a FHIR object? And basically what we settled on was splitting the top level attributes from a FHIR object into individual fields based on the FHIR definition for that resource type. So top level attributes just become standalone fields. We chose to capture primitive types in your more basic field types like integers, varchars, timestamps, and dates. You could put all of them into supers, but it ends up being harder work at query runtime. I think it's much nicer in almost all cases for users to take that approach. So one of the things we did in the ETL, of course, because you can have extensions and metas and things like that pushed into any type of primitive type of attribute within the FHIR spec. So basically the ETL will process that, capture it in an alternative field, and then just return and capture what the original intended primitive value might have been for that field. So then the really complicated thing then is capturing complex types using the super type. So finally, for table layout, we started capturing as standalone fields things like last updated, which are part of meta. So it's just kind of copied into its own standalone field. And then we have various, at OneUp Health, we have various internal use partitioning fields that also become their own standalone field that's not really part of the FHIR spec, but it's kind of like a necessary thing in our ecosystem to capture and make it convenient for usability, basically. As far as like cost, I think that's probably another thing folks are interested in, cost and kind of performance and capability. Like, well, how many nodes do I need? What type should they be, and what is this going to end up costing me, right? So in the old days, AWS used to have two different node types, the DCs and the DSs. So DS stands for, or DC stands for dense compute, which is basically SSD drives, not too much space on them. And dense storage was like a magnetic solution. They've since discontinued that, and they've moved on to only offering DC2 and RA3. So DC2 is the smaller node type. It's very inexpensive and cheap. I talked earlier about our first cluster with demo synthetic data and how performant that was. So you can see here, like on a single DC2 large node, that doesn't look like very much space, 160 gigabytes, right? And I guess it really isn't, but when you factor in compression encodings, it ends up being actually a reasonable solution. Just a couple of small DC2 large nodes can capture actually a remarkable amount of data. So at 25 cents an hour, I think that comes down to about $150 a month for a provision cluster. And again, you can throw as many queries at it as it can handle or you want to run, etc. So for our deployments, though, I think for our customers, we've settled on the RA3 plus system. So what AWS tried to do here was break out of this model where you would need to scale up and down your clusters a lot to capture data. So they've moved to this model where their infrastructure sort of moves data between the disk on the cluster and S3. So they say 32 terabytes of managed. I think that's what's on disk. And then you've got further scalability out toward, I think, 100 terabytes for S3. So I'm not exactly sure. It's part of AWS's secret sauce, how exactly that logic works, but we haven't seen any access issues or noticed any slowdowns, anything like that. It's kind of a nice way to make sure you're not filling up disks and interrupting ETLs and stuff like that. So we're seeing, I think, a monthly cost of around $750 before reserved instance pricing. You can get that down again by like 70% if you wanted to do something like that. So the last slide I have before I plan to do a little bit of a demo too, just to kind of show how tables are set up and how one can access nested attributes, etc. But finally, just a few links, and I can share this Google presentation out too, so you all have access to all this. So basically, Redshift is SQL, I guess, kind of like from a syntactic standpoint, you can call it Postgres. It's interesting to consider the compression encodings because there just are such great advantages with reducing storage requirements. The super data type is interesting, as well as the link to querying semi-structured data. And probably most people should be, I think, interested in the RA3 node type, which is where kind of like a lot of the development in AWS is going nowadays for query speed ups, data sharing across clusters, etc. And finally, row level security, I think, is worth discussing, especially in kind of like a HIPAA type of setting where you'd probably want to have pretty fine-grained access controls. So that's kind of the end of my presentation before jumping into the demo. Did anybody have any questions? Yeah,
we might just, oh yeah, go.
Yeah, one quick question. So, and apologize, I'm not very familiar with Amazon services. So, does Redshift actually solve the scaling problem? Like, I mean, going beyond one, because I believe it's a Postgres-based type of offering, but I don't know whether it solves the problem of, running a single query on multiple nodes.
Oh yeah, so that's I think kind of just handled by the engine and the query planner and things like that, kind of behind the scenes. So usually the leader node will figure out where data is. It's partitioned across multiple nodes, and then the queries are broken down, and the query is broken down probably into multiple queries which are run against individual nodes depending on where data is. So it's hard to say how that exactly works. I don't think Amazon is going to release info on exactly the kind of logic they use, but that's kind of the gist of it.
But you can use multiple nodes, like you can set up as many nodes in your cluster as you like.
Yeah, I mean, there is a hard limit, but I think probably most people aren't going to hit that. It used to be 100 nodes, but I think AWS has gone beyond that. So yes, it's sort of dependent on your demand. And so they have a couple of other offerings too, like they've got a serverless offering. I'm not sure if the cluster ever gets entirely spun down. It might during times of no demand, but then it scales up and adds nodes as demand increases. Also, there's like concurrency scaling, I think, and you can kind of give it like bounds of, I want to cluster between 2 and 10 nodes, and then it sort of scales up and down how many nodes are provisioned depending on what the demand is, basically.
Oh, well, I think you should just dive straight into the demo.
Yeah. Okay, cool. Just a moment here. Okay. Just a little bit of a note here on kind of our layout. So we've got all of our FHIR resource types deployed into a single schema, in this case called FHIR R4. That's the bulk of where our data is at this point. So you'll see tables here for pretty much any resource type that you might encounter. That doesn't necessarily mean that we would have data for each across all those resource types, but at least we can provision for them and capture whatever we need to. So this demo is going to focus on explanation of benefit. And then if we drill in here, a few things to point out here. So all tables are going to start with the resource type field. ID is kind of an internal one that we've identified, but in all other ways, this table layout is going to map one-to-one, both with what the FHIR definition says it should have. So we didn't want to put them in alphabetical order. We want to make that, kind of match as closely as possible to the FHIR definition, just to make usability and adoption absolutely as intuitive as possible. So you can see there's a few field types that are in primitive types, like we've got our resource type in as a varchar, ID as a varchar, etc. Then we get into certain ones like meta, for example, that are supers. So those are all going to be used to capture complex types, right? Where we might have unnesting and other types of operations like access via dot notation type of usage patterns. So in this database, so here's a little quick query, and I've basically identified a single record with multiple diagnoses so that we can sort of showcase how one nests and accesses in that unnested field. So if we run this guy real quick, so we can see that we've got an array here with multiple objects inside. So each element of this array is going to have its own sequence number in this case. We're going to have like an upper level attribute called type, which is got its own nested objects inside. Then there's another coding inside of that, which is also an array, and on down to diagnosis codable concept, for example. Then we've got our coding in there with 2 objects, okay? And then on down to the next element here. So we've got a single field right here, diagnosis is capturing, in this case, 10 diagnoses. So if we move down to our next query here, then we're going to do a cross-join unnest here on the diagnosis field. So eob.diagnosis, we're going to alias to diag. And then this is a handy little system. In this case, we do have a sequence to identify like the position of each element. But an alternative to that is that you can create your own index, and this will count up from 0. So it's 0 indexed in that case. So now when we run this, we're going to end up with 10 results returned, 1 for each of the elements in the diagnosis field for this record. And this will be just our single element here. So now you can compare your diagnosis index with the sequence identifier. Okay, quite predictable. And then to add just a little bit more complexity here. Now, whenever we encounter an array here, we're probably going to be doing like an unnesting operation. You can specify like 0 index, 0, 1, 2, 3, if you know exactly what element you need to use. And you can access those attributes via dot notation and actually hard coding the position in your array. I never think that's a great approach to programmatically try to access my data, with, I guess, the concern that elements from one record may shift in position as we move to other elements. It's better probably to just identify them based on what you want to do. Like your principal diagnosis here, you can run your query, you can do an unnest, and then do a filter based on whether or not display is set to principal diagnosis, for example. So in any case, then we've got our same unnesting operation up to this point that we had in the previous query, but now we've got 2 more unnesting operations because we've got 2 nested arrays here. We've got the first one at type, so diag.type, we're going to call that type, and then we're going to do an unnesting again at coding. And then we add a few things here in just our select portion. What was I saying about performance? Okay, there we go. So then we've got our single values here for diagnosis type. We've labeled it as diagnosis type coding system, and then the diagnosis type code. So this one is principal. The next one is also listed as principal in this case, and then a bunch of others, right? So then, I mean, depending on what your use case is, it's kind of just a matter of walking through your data and setting up the filters, use cases, tuning your query to what you need it to do. So that's kind of what I had in mind for kind of like a basic demo of this. I don't know if anybody has any questions or further requests or anything like that. Yeah, go ahead.
Yeah, thanks again, Shane, for the presentation. One other question that I have is, so again, I think this super type is a Redshift specific thing. I think it's not a Postgres thing, I suppose.
Yeah, that's true too. Yeah, so that's what
yeah, so how does it actually, I mean, if I understand correctly, you only do like, doing the schema thing only at the first level. And then, beyond that, they are just like free schemas, like it can, like it's like a JSON basically, right?
Yeah.
So does it, when you do that, does it have a schema inference, or is it dynamically? So when you do this kind of like EOB.diagnosis, for example, is it, or you go deeper, for example, is it dynamically finding those fields and then
That's correct. Yeah. So it is dynamically finding them. And if it doesn't find it, it returns a null. So one of the things to keep in mind here is like when you're running your queries, you end up doing, for example, if you want to run a big query to access a bunch of stuff from, for example, explanation, you don't want to include like a big tree of cross joins all in the same query. You probably would use separate CTEs or something like that, because as soon as you get one null somewhere, your result set then collapses, right? So like if you're trying to do unnesting across not only the diagnosis field but some other field that's also got nesting, I recommend always to put that into a different CTE for exactly that reason, because there is no schema defined. So it's looking for where it finds defined attributes. And if it doesn't find that, it returns a null, right? So then when you do a join on your null, then you're going to exclude a whole bunch of data from other fields as well. That make sense?
Yeah. So then my follow-up question was on performance, because if you said earlier that you were using, if I remember correctly, you were using Parquet with Athena, right?
Yeah, that's correct. Delta Lake, which is,
right.
containers, but yeah.
Right. But then I am a little bit surprised that having like a columnar format, and I suppose Athena has scaling capabilities as well. I mean, horizontally scaling queries.
Yeah.
It was an order of magnitude slower than your
Right.
JSON-based kind of, or
Well,
schema-less based.
it is binary JSON though. So, and I
Oh
can't
yeah,
really,
yeah. It's JSON,
so I
right,
can't,
JSON.
right. So I can't really comment on how they achieve that. Unfortunately, they don't actually, it's, I mean, it's proprietary, right? Redshift is a proprietary thing. So I can't really comment on how they achieve that. But I imagine it has to do with optimization across between the compute and storage, right? Which is what you're getting with a data warehouse versus like a data lake type of approach with Presto or Athena and S3, right? So it's partly
Yeah.
that is a problem, right?
Yeah, I'm guessing there is a secret sauce there because I mean I was
Yeah.
experimenting with the JSON-B data type of while
Yeah.
in some cases it was
Yeah.
like the query planner was making terrible decisions in especially.
Also keep in mind that Redshift is really kind of like it's seen as more of an analytic database than Postgres, right? It's also a columnar database. So that's going to be similar to IO overhead, like a Parquet file in that way. But it will pretty much always outrun a transactional database like Postgres or MySQL by orders of magnitude for analytic queries, right?
Yeah, but the thing is that you are providing the columnar information only at the first level. So then beyond that, I think it doesn't do the. Do you think that it will doing like
No, I don't think it is. But I don't know actually what it's capturing for metadata, right? I'm not sure about what exactly is captured from it. Possibly there's a scan of metadata, but I don't know how they keep that up to date and so on.
Yeah, thank you. I have one other
Yeah.
question, but let me see if there are other people who have questions for you.
Go for it,
Yeah, I
Bishu.
just wanted to ask, what is the size of the data that you're querying for this?
That's a good question. I can show you for this table here. Let's just run a query. I've lost track of how much. This is all from Cynthia, I think, 7 million records. But also I have,
Okay.
it's a little bit cheap because I've got this one record specified in my where clause. So yeah. And this is a small cluster. I think it's 1 or 2 nodes of DC2. So it's just a small demo cluster.
Okay, thank you.
Yeah. Dan?
Got it. Okay. Yeah. So that was kind of what I was getting at a little bit. I guess I'm curious, like, kind of in that vein, are you finding like that there are a standard set of views that have wide applicability, or that most users kind of need custom views for kind of the data work that they want to do?
It's pretty custom for what people are really kind of interested in answering. We have our standard views, which we generated back in Gen 1 SQL on FHIR, actually. I would have to look actually how much those are accessed versus the sort of like custom solutions. I hear more about custom solutions, so then that's maybe where my mind goes, right? But then I can't really answer the question how much the other ones are used.
Got it. Oh, and I lied. One more follow-up. Are you finding that folks are using like kind of custom stuff because FHIR is a little bit weird to work with?
Yeah, it's kind of mixed, right? Like we've got quite a few customers running ad hoc queries, but then we're seeing some connection with BI tools as well for generating reports. I don't know if there's anybody connecting with like a Looker with a broad audience of folks, watching dashboards and things like that yet, but it seems mainly restricted to like weekly report generation, stuff like that.
Got it. Awesome. Thank you. That's really, really interesting.
Of course. Yeah, go ahead.
Yeah, so
Rishi.
one quick follow-up on previous discussion, and then I have a question on view definition. So I suppose, I mean, I'm just curious, did you try just having like a super type, just one, I mean, at the root level? And I suppose it was way less performant. Was that the reason that you went ahead and had separate types and then one level for the initial like fields?
Yeah, no, I never did like capture the entire resource in a single super. You could do that, but it would kind of defeat the purpose and part of the efficiency with columnar store, right? So in that case, if you want to do that, you'd be evaluating the entire and fetching the entire resource at every query, right? Part of the performance improvement with a columnar store is not having as much IO for all of the fields that are of no interest in that query use case, right? So I never tried that, but I have a hard time imagining that would be the right way to go, both from intuitive use as well as performance.
Right. Yeah, and
Yeah.
where I am getting with this is that I am guessing, I agree with you, and I am guessing that if you start querying deeper fields, like a few level deep, and then you have large amount of data in those fields, then it might, because if it can't do the columnar for those deeper fields, then it may have some performance issues. I'm just guessing. I don't know.
Right. Yeah, so I guess if there were a use case where someone was accessing a attribute that's deeply nested, maybe you could make an argument to split that out into its own field. But then, then at that point, you're kind of going back on the initial design plan to make it intuitive, like a FHIR spec design. And then, yeah, then usability may be somewhat damaged by that too. I would say probably just let the cluster work through it, because it's not really that expensive to access those nested attributes anyway.
Right. Your initial implementation for doing the Parquet mapping, was it based on that spec, like SQL on V1
Yeah,
spec?
it was. Yeah, so we programmatically developed a schema, and it just became like pretty huge and unworkable. In the end, you end up making some compromises. You have to cut some attributes out. You can't nest too deeply in some cases. And then we had issues with capturing attributes, and then we ended up with different schemas for different accounts, and it was kind of like a mess. It wasn't really that reliable. And it's really hard to make sense of that. Right. You're probably going to be, if you're sharing data via Parquet, you're probably going to be just creating custom Parquet files on like a per share basis, if you want to call it that. It's not really quite like people sort of, I think, without thinking through it in the moment, in the place where you've got to like manage this type of solution. I think that confusion tends to arise.
Yeah. All great points. So one quick last one. So do you have like an implementation for view definition, like SQL on Fire V2? And I suppose
I don't know if I can show you our specific views that we have defined.
But I mean, you have like, you translate like a view definition resource into like a SQL query. Is that how you do it?
Oh no, so we have our own internal custom views. Like we haven't started using the HL7 view definition. So that's coming for sure. Yeah, that's something we're really excited to start working on as well, to provide those view definitions. Because I think, just seeing the community adoption of SQL on Fire is really great to see. I think usage will improve, and we definitely want to be able to provide our customers with all of what's going on in the community, including view definitions. But it would be just a matter of like creating a query that that yields the view definition, right?
Right. Yeah.
Question, John?
Probably more of a wrap up given the time, but
Oh wow.
I also did want to just say we're planning on having a Parquet over the coming weeks. We've got some ideas for addressing some of the problems that you mentioned relating to Parquet. So it would be great if you or some of your colleagues could come along and participate in that chat and bring your experience with trying to implement FHIR schema and Parquet and all that sort of thing, because we've got a few other folks who've had a crack at it as well. And it'd be great to get all the minds in the meeting and sort of sharing those experiences. So
yeah, for
there's
sure. I think we would love to be part of that discussion. I came in a couple of weeks ago late to the meeting when we were kind of like, the discussion was kind of petering out about Parquet usage. So I felt a little disjointed to just jump in with our experiences at that point. But that's why I thought during the right time, I think it would be fun to collaborate and see what's going on with Parquet.
Yeah, awesome. So I just posted a link in the chat. There's a poll up on Zulip. If you want to just indicate what would be a good time for you, that would be awesome. And with that, I might let everybody go, and hopefully we'll see you back again next week, and hope you have a lovely week.
Yeah. Thank you.
Thanks.